Okay, welcome back. All right, so for the next part of this, we're going to talk about a thing called scope. I think this gets skipped a lot in a lot of programming classes and books and manuals um, because it's just kind of assumed and it's kind of interleaved in all the other lessons, but I think it's important to talk about. We've already been using scope. We've already been sort of talking about what it is. But now that we've looked at functions, now it's kind of important to look at it a little bit closer and actually explicitly call it out of what it is and what it does. Scope sounds bad, but it's not. All it is it's just what variables are available for you to use at any given time. What variables can you see? What variables can you use? Okay, and it's important to get this kind of it's important to get an accurate picture in your mind of how scope looks and how it works, because if you think about it in the wrong way, or if you have the wrong picture inside your head when you're thinking about this, programming becomes impossibly hard because you just don't understand what's going on. Okay, so we're going to take a look at this in two parts. We're going to just look at the scope of variables, and then we're going to add in what functions do. All right, so here we go. So first off, when you have a program, okay, if you have, pound include using namespace, okay, and then you have your main. Go away, Java. So if you have this, basically everything we've been doing so far, we've been defining variables in main, okay? And the key is that main has its own scope. All right, so I'm going to kind of highlight here this idea of orange being main's scope. All right, so if I say int a equals 5, then immediately after that I can access a. All right, and anytime that I'm in the scope of main, I have access to the variable a. The key is that main's scope is not the only scope that we have access to when we start our program. There's also a thing called the global scope. All right, the global scope encompasses this entire file. All right, so I can create a variable up here outside of main called int global var b equals 10. Okay. And now the idea is that this global var b is available to everything that's in the global scope, this green. Okay, so if I define other functions, anything in this file, they're all going to be able to see and use global var b afterwards. Okay. Not only does main have its scope, but anytime I use either an if statement, a for statement, a while statement, or a do while statement, those are also going to create their own scope. All right, so if I say, in here, if I just say while true, and we're going to look at this in Visual Studio because it'll be a little less cramped, but I want to be able to highlight here. If I say while true and then I do stuff inside of this while loop, inside here, if I create a variable int c equals 10, let's get ourselves a little bit more room here. Let's extend these little highlights. As soon as I start this while loop, I have now entered a new scope. I have entered the scope of the while loop. Okay, this variable c is part of the scope of the while. So now in here, I can access c. So I can say cout c. But I can also access any of my parent scopes. All right. So this while loop is inside of main. That means I have access to the scope of main. So I can also print out a. And main is inside the global scope of this file. So I can also access global var b. Okay. And the scope that each one of these is coming from, I can highlight it. This c is coming from the while loop scope. A is coming from main scope, and global var b is coming from the global scope. Okay, I have access to all three of those inside that while loop. this program, if I were to type it up, which I'll probably type up something similar here in a minute, this will compile. However, if I then try to say cout C after the while loop, I have left the scope of the while loop. I'm now only in scope of main and global. And so this line right here will not compile. Does not compile because I'm out of the scope of that while loop. Anytime you enter a new scope, a new region of memory is designated for you to create variables and use them. Anytime you leave a scope, those variables and the data are destroyed. That is important, okay? So it's not just here that I don't have access to C, it's that C will no longer exist. C++ and C will reclaim memory that C took up. It may not do it right away, but from a programming standpoint, you have no longer had access to it. Okay, that is important to understand. All right, so let's jump over to Visual Studio here and start taking a look at this. Okay, so let me see. I will say int global var a equals 10, int global var b equals 20. And then in here I'll just say int a equals 1, int b equals 2. And then let's print it out. Let's just say global var a b, and then print out a and b. And I'm going to have access to all of these. Should print out 10, 20, 1, 2. And you see 10, 20, 1, 2 worked. All right. I can also show that the while loop that I was talking about, while true, int C equals 100, cout C, cout A. Let's put them on different lines. Cout C, cout A, cout global var A. On this one, I should get 100, 1, and 10, and it should work because I have access to all three levels of scope when I'm inside this while loop. Actually, it's going to do it infinitely because I forgot to put a break in. There we go. That's more reasonable. 100, 1, 10. Okay, but now if outside of this while loop, if I try to access C, it says there were build errors. It says C, undeclared identifier. If you remember from the variables, undeclared identifier means that it's a variable that C++ doesn't know about. Even though I defined C right up there, it was inside the scope of this while loop. When I left the scope of the while loop, C no longer exists. Okay, that is important. Another interesting thing that you can look at is the idea of masking and the way that scope works. So let's shrink our variables down here. Okay, so if you'll remember, I basically said over here, I said that when you're inside the while loop, you have access to the current scope you're in as well as any parent scopes you're in. So while has access to main and global. Okay. When I'm inside one scope, I cannot define a variable of the same name twice. Okay, so I cannot say int a equals 10. All right, because C++ is going to say, I have no idea what you're trying to do. I mean, it doesn't even make sense. A, redefinition, multiple instantiation. If I did this, C++ afterwards, if I tried to reference A, would say, which A? You created more than one. The same thing is not true when you're talking about different scopes. Okay, so what I'm going to do is I'm going to say int A equals 10, int B equals 20, int C equals 30. And actually, let's make it just 1, 2, and 3. Okay. And then in here, I can say int A equals 10, int B equals 20. And then inside this while loop, I can say int A equals 100. And now if I say cout A, B, C, and then let's label this. Let's say inside while loop. So I have three definitions of A. I have a global version of A, I have a version of A inside main, and I have a version A inside the while loop. Okay, and what I'm going to do is I'm also going to put little print statements out here so that we can see what all three of these variables are. Let's say before the while loop, and then after the while loop. So what I've done here is anytime that you have scope, you get a new section of memory, which means you also get a new template for naming variables. If you choose to name a variable the same thing that exists in one of your parent scopes, C++ allows you to do it. It's called masking. And what it will do is as soon as I've defined A inside main, anytime I use A afterwards, it will refer to the A that is inside the scope of main. This A will still exist, but it will be very difficult, if not impossible, to read it because I have masked it. When I'm inside the while loop, this A now masks this A. So now inside the while loop, I'm only going to be able to access this one. When I come out of the while loop, all of the scope that was in the while loop is destroyed, and all that's left is the scope of main. And so now, once again, in here, it's going to read the A that is inside of main. Okay, so if I look at the prediction, or if I try to predict what's going on here, when I say before the while loop, print A, B, and C, it's going to take A and B from main, so it'll say 10, 20, and then it'll take C from the global scope. So it'll be 10, 20, 3. Inside here, A is now masking this one, so now it's going to be 100 from while, the scope of while, 20 from the scope of main, 3 from the global scope. After the while loop, when I come back out, it'll go back to what it was before. It'll say 10, 20, 3. Let's test it, make sure that I'm not just making this stuff up. There we go. So, kind of like I had said, let's try to get it so I can get both on the screen here. Here we go. So before the while loop, 10, 20, 3. It grabbed these two variables and then C from the global scope. Inside the while loop, 100. It grabbed the 100 that I put inside there, 20 and 3, grabbing from main scope and then the global scope. And then after the while loop, 10, 23. It went back to what it was before. All right. So one thing that I will mention, I will say this a bunch more times in this video because it's important. Do not use global variables. Okay, I show them here because the global scope is important when it comes to function names, but never use global variables. Okay, the fact that I can do this is just something that I'm going to show you that yes, it does work, but don't do it. It is a bad programming practice. A lot of really bad code comes out of when you try to use global variables. So I'm showing them here. Don't use them. Okay, so now let's talk about functions. All right, so functions throw a little bit of a wrench in it. It's really simple what they do, but you have to understand how scope works with these. Okay, so I say pound include whatever, and then we'll just say the using namespace up here. Okay, and so now once again, I'm going to label in green my global scope as the entire file. If I define a function, we'll call it double my function. And I have a variable, we'll call it int a as a parameter. Okay, this function, well, we'll get to this. Let's draw a main first. So, keeping with the color scheme, main has a scope. Okay, so let's say I create int a equals 10 right here. And then just for the hell of it, we'll create a very evil global variable up here called int a equals 1, just like we were doing. Okay. All right, if I make a function call, right after I define a, if I say my function 100. So if you remember from the last video, this is how you make a function call. The name of the function, open parentheses, values for the parameters, close parentheses, semicolon. This now jumps up here and starts running my function. Every time you make a function call, a new scope is created for that function. Okay, let's use yellow. A new scope is created for that function, and the parameters are a part of it. Okay, so as soon as this function is called, a new scope is created for my function, and all the parameters are inserted into that scope, and they are considered part of that scope. The other thing that happens, though, is I leave the scope of my calling function. When I call my function with 100, not only do I enter a new scope, I leave the scope of main. Okay, so if I said, let's just say I said int b equals, well, that's hard to read, well, int b equals 20, and then up here in this function I tried to say cout b, it would not work, because b would be a part of the scope of main, and I left the scope of main. I do not have access to it anymore. I have entered a new scope. My function, however, you'll notice, is still a part of the global scope. Because my function still exists in this green global scope, I may have left the scope of main, but I do not leave the scope of my of global. Okay, so if I were to rename this, B and I tried to print out A, this would work because it would grab the A that is up here in the global scope. When my function returns, when I come back, that function scope, the yellow, is destroyed, much like it was with the while loop, and I return to the scope of main. Okay, so down here I can once again say cout A and cout B, and it works because I'm back in the scope of main. Okay, it's important to have this picture that every time you call a function, a brand new scope is created for you that you are now living in. You leave the scope that you were in before, and you are given a brand new scope. This global, everything stays inside of it, and so everyone has access to the same scope. If it sounds weird, if it sounds confusing, I promise you it makes a lot of sense when you start using it. But you need to first get this idea that each function has its own scope. When you call, a new one is created. When you return, that scope is destroyed, and you return to the calling function's scope. Okay, so let's play around with this a little bit. Okay, so I'm going to leave these global variables because I am evil. I am going to leave A and B defined like that, and then I'm just going to create my function. We will have a variable called, I don't know, let's call it B, or let's call it C. And let's just say A, B, C, and L. And we will say inside function. And I missed a line brackets there. Okay, so down here I'm going to say before function call, and then say after the function call. So my function, call it with a value of, let's do 300, and then say after function call. Control F5. Alright, so before I build this, quick prediction of what it's going to say. So this first statement is similar to what we did before, nothing special about it. A, B, and C. It grabs A and B from main scope because that's the scope that it's closest to. Grabs C. Can't find C anywhere in main scope, so it goes to the global scope, finds C right there, and uses it. It's going to call my function. I'm going to leave the scope of main. A and B are now no longer inside my current scope. And so now in here, when looking for A and B, it's going to say, is it inside my function scope? Nope. Go to the global scope. Ah, there they are. So it's going to print 1, 2. C, this parameter, is part of my function scope, so it's going to print the parameter value of 300. When I come back after function call, everything's going to go right back to what it was before I made that function call. A and B, 10 and 20, C is 3. So, give the compiler an opportunity to prove me wrong, and it doesn't do it, because that's exactly how it works. Before function call, 1023, inside function, 1, 2, 300, after function call, 1023. So this idea of scope is going to be really important, especially if you, so first off, if you ever have a naming collision with variables, it's going to be important to understand this, because sometimes people will do this by accident. They'll name two variables the same thing, not realizing that they're in the same scope, or that you're masking a variable that's in the scope of the others. So understanding what's going on is really important. The other thing to understand is this kind of gives you the start of an idea of how function calls actually work with variables in memory. And we're going to, in the next video, hit that a lot harder. We're going to talk about the call stack and recursion. And understanding the fact that functions get a new scope every time they are called is really important, because it's going to help you understand why recursion works the way that it does. So, until then.